Hey, in this video we're going to talk a little bit about moles. Moles, hopefully you remember, are a way of counting small things that we can't see. Little particles like atoms, molecules, formula units. These are all different words for little tiny particles that we need to be able to count in order to do calculations on chemical reactions. But we can't see them, so we can't just like take a nuclear tweezers and count them by hand. So we need something to count them with. Okay, so a mole is just a number. It's a unit that we use for counting things. And just like a dozen is 12, for example, if we had 4 dozen donuts, you know that to figure out how many donuts that is, you would just take 4 times 12 donuts, because a dozen is 12, and 4 times 12 is 48 donuts. Similarly, if we're counting atoms, we would just use moles instead of dozens, because dozens of atoms would be kind of stupid. And if we had 4 moles of, say, iron atoms, then we would just do the same sort of thing. We would take 4, but in this case we wouldn't take times 12, because a dozen is 12, but a mole isn't 12. We would take 4 times the number for a mole, which is 6.022 times 10 to the 23rd. This is Avogadro's number. And once we punch that into our calculator, that'll give us how many atoms of iron we need. Now the way to do that is to use that special scientific notation button. So we're going to take 4 times 6.022, and then you just hit E23. Hit equals, that gives me 2.4088 E24, and the way to actually write that on the paper is 2.4088 times 10 to the 24th atoms of iron. And it's pretty much as simple as that. Okay. One other thing you can think about that might help you to remember whether you need to multiply or divide is you can use unit cancellation. So for example, if I have the question, how many moles is, say, 6.99 times 10 to the 25th formula units of NaCl, we can set that up in a special way so that we know whether we need to multiply or divide by Avogadro's number. The trick here is just to start by writing down what's given to you in the problem, 6.99 times 10 to the 25th. Don't let that word formula unit scare you. That's just the word for very small particles of an ionic compound, like sodium chloride. So 6.99 times 10 to the 25th. And then what we're going to use is called a conversion factor. It's like a big fraction. I'll leave that empty for now. And in the end, I want to get to moles, because that's what the problem is asking for. Moles of NaCl. Now the trick to this is that whatever unit you start with in this problem, you want that to go down on the bottom of that conversion factor every time. So I'm going to write formula units in the bottom, and whatever unit I'm trying to get to, moles, that's what's going to go on the top. So then the last piece is just to fill in these numbers, and you just have to stop and think about, what does this mean? Well, what this is asking is, how many formula units are there in a mole, right? 1 mole is how many formula units? Well, 1 mole of anything is Avogadro's number, 6.022 times 10 to the 23rd. And now you can see that since Avogadro's number ended in the bottom of this fraction in the bottom of this conversion factor, that means I have to divide. So I'm going to take 6.99 times 10 to the 25th and divide by Avogadro's number, and that's going to give me my answer. This makes sense just logically, right? Like in the last problem, I told you you have 4 moles. So how many atoms that is should be 4 times a mole. Well, this time I didn't tell you how many moles. I'm asking you how many moles, so it just makes sense that you would do the opposite. You would divide by Avogadro's number instead. So here we go. That is 6.99 times 10 to the 25th divided by 6.022 times 10 to the 23rd equals, and I got 116 point lots of stuff. I'm just going to write 116.07. In fact, no, I'm just going to write 116. These numbers, this number here has 3 sig figs, so I'm going to stick with 3 sig figs in my answer. So that's 116 moles of sodium chloride. And that's how you do it.